Okay, so greetings to the Sector 39 Permaculture Design course. This is our second week, and it's going to be a 24-week journey. This, um, in the past we've crammed all of this into just 12 days, and what we decided to do this time was to spread it out over 24 weeks and allow people time to digest the information, to think about it, ask questions, to feedback, and to make it more like a journey where we're traveling together into this world of permaculture. And there's a lot of different ideas and thoughts and insights come, and we're very interested to share those ideas. And as we move into this course, I'm going to be really asking you for your feedback, and we want to learn about your experiences of using permaculture in your home context. What we've seen so far is it can be very inspirational to see how people take these ideas and then sort of transform them and make them relevant to their own circumstances. And that's really what permaculture really is all about. It's a very flexible thing, and also to say this is an experiment. We've done a bit of online teaching in the past, but we've not tried to teach across different time zones and different countries and all at the same time. So you'll forgive us if it's a little bit ramshackle, but we're learning fast, and as we move into this, we hope to get a slicker operation. But also, we need to understand what other people are able to do, whether you're able to, in terms of broadband or technology, the data, the things that might be a limitation. And I very much want you to work with these ideas each week. So don't, so we can begin this journey right away. And each week we can kind of add to that process. That's how I'm seeing this. So, okay, there we go. Now, as you may or may not know, I'll tell you a little tiny bit about permaculture and where it's come from. And I did touch on this last week. And yeah, also just to say for clarity, each one of these lectures we are recording and we will post on YouTube as well. So all of this information is available in different ways. I've pre-recorded these slideshows already, and they're on today's page and also on the YouTube page. And we'll also kind of go through it live, and we'll capture that as well. So hopefully, if anyone does miss anything, they have the chance to come back and catch up. So here we are on part one of our journey, and permaculture it's a way of thinking. It's a design system, a way of solving problems. It's a way of reaching consensus, of reaching agreement with other people, especially about more complex things over a longer period of time. The question is, how do people come together to make agreements and to develop mutual understanding? Because I think without those things, we're never going to tackle the challenges that we have around us in a meaningful way. And so much of what we can be guilty for humans is coming up with very short-term solutions that don't really solve our problems. So there's a starting point to think about. In week one, last week, we talked about the ethics of permaculture. And this symbol here that I'm using is the Chinese character for change. And in fact, there's a whole philosophy, sort of Taoist philosophy, of thinking about how we deal with change, how, and in fact, how the world around us is constantly changing. Nature never stands still. And so, as much as we might find the idea of change a little bit scary, or sometimes we fight against change because we want things to stay the same, but actually, change is the only thing that's inevitable. It's a constant process. So, the only thing you can be certain of is that tomorrow will be different from today. It might be similar, but in many ways, it's going to be different. So nature doesn't stand still. And the way that we deal with change, permaculture brings us into that mindset, is it encourages us we are encouraged to observe and interact, to be ready to take in new information, build alliances with other people, and to understand that we're part of a big interconnected living system, the Earth. So permaculture ethics, which we looked at in deeply last week, is we summarize by saying earth care, people care, fair share. As I went into, it's actually much more nuanced than that, and much cleverer than that. But the ethics in permaculture understand that we're all trying to feed ourselves. We all need energy. We all need food. And that shouldn't set us into competition with each other, but we should realize that we are in collaboration. Okay, so just a little bit of a summary from last week, just to try and get us into thinking. And this is serving as a really broad introduction into thinking about permaculture. As each week of the course goes on, we'll focus in more and more on the detail. But what's important is that we're all together in the bigger picture, that we understand the bigger picture first. So the origins of permaculture come from an Australian forester. His name was Bill Mollison, and later in life he became an academic and became a professor at Hobart University. And he was very fascinated with the natural world and forest systems, and had learned a great deal from working in that context. As he became a teacher, he came across, they were wrestling with the issues of the day and the beginnings of deep concerns about the long-term well-being of the planet, of global ecosystems, concern about war and conflict and greed and materialism, industrialism, and pollution. And that led Bill Mollison to realize that we needed to be exploring alternatives, that we need to find a more nature-friendly way of being. And he collaborated with one of his students, David Holmgren, to create a book called Permaculture 1. And they created this word permaculture, permanent culture, a permanence of culture. They created that word because they realized that there wasn't a word in the English language for long-term permanent agriculture, or for agricultural systems perhaps built around perennials. Now we have agroforestry, we have regenerative agriculture, we have these other words coming into the lexicon, which is great, because that means is that somebody talked to me about syntropic agriculture. What's great is if we are exploring these ideas further, going back to the 1970s, the word permaculture, didn't exist. There wasn't a word to describe these things, and permaculture was coined for that very reason. So as we move into this, here's a few opening thoughts that come from Bill Mollison. And also, perhaps I just need to add one more thing really at this stage, which is that sorry, someone's trying to phone me. I don't know how. Okay, who is this? Sorry. There's people trying to get it in, and I can.
Still,
Yep.
am I still a co-host?
I think yes, you are. I think so.
Okay, just in case.
Yeah, no, sure. Because I'm trying to What's that say? I'm being rate limited. Try again later. Oh, I don't know. Okay. Sorry, I'm getting lots right now. Seeing who that was messaging me. Sorry, folks. Okay, so sorry about that, folks. Just getting some messages through. Okay. Let's just again, we're warming up. We're getting into the flow of this. A summary of what Bill Mollison learned from his interactions with nature, and which maybe helps us begin our permaculture sort of thinking, is he's telling us to work with nature rather than against it, to assist rather than impede natural developments. It's asking us to work with nature. And the question might come quite quickly was, how do we do that? Well, we observe, we make observations, and let's carry on. Work with nature rather than against it. Assist rather than impede natural developments. So we're going with the flow. He also advises that the problem is the solution. Everything works both ways. Now, I touched on this last week, the idea that actually the problem is the inverse of its own solution. That rather than seeing things as being disconnected, unconnected, oh, there's this problem, there's that problem, is actually they're all intrinsically related, and we only are solving a problem if we can solve the cause of that problem, rather than we're constantly dealing with the symptoms. Now, we'll come back to these ideas again and again as we move through the course. These are kind of big starting points, if you like, to get us going. Make the least change for the greatest possible effect. The way to be smart is to through study and thought is to find the tipping point, find the leverage point. How can we can always solve problems by throwing resources at it. We can always solve problems by throwing money at them. How do we solve a problem? How do we create the biggest impact with the smallest input? That's what we're working for in permaculture. That's what we're thinking about. So, so on we go. So this next principle is a really exciting one. The yield of the system is theoretically unlimited. Yield is theoretically unlimited. What that means is the ability of any system to produce is maybe only limited by the imagination and the skill of the designer. So what you might be able to achieve through your permaculture design has potentially unlimited outputs. So, and again, we're going to expand on these ideas, but that's what we get when we look at nature. You look into a tropical rainforest system and you're seeing so much complexity, so much dynamic actions within that. You realize is that what's the potential of any system? It could be, it's unlimited. I think Bill's really opening us up to the idea that because in nature everything cycles, everything is reused again and again and again, is if we can build functional, harmonious system, then there's literally no limit to the productivity of that. So that's a fantastic thing to have in mind. Another one of Bill's observations is everything gardens. Now, what does he mean by that? What he means by that is everything is actually interacting. Each element, every living thing is interacting with its environment in some way and making changes. And effectively, gardening. Every action that you do, you might be promoting one species and inhibiting another. And your choices, think about how any living thing is actually doing the same thing. A monkey going through the forest would select those fruits that it's interested in, and in the process, it promotes the dispersal of the seeds and the spreading of that fruit. Now, this seems to work at every level within natural systems. So this, again, giving us a little insight into how permaculture might work. Now, I wanted to just look at, and I'm going to come back to this later, but so permaculture, it had its origins back in the 1970s, when the world was beginning to really wake up to what they called then the limits to growth model, and realized that it's the beginning then of thinking about sustainable development, about the long-term impact of development. And Bill started applying and working with the sort of permaculture concept ideas on real life examples. And he says in his book, The Designer's Manual, it wasn't until 1981 that he felt he was ready to turn this into a teaching system, and he was ready to deliver the first PDC. And the experience of that is collated in this Designer's Manual book. And I put we'll explore some of the images from that in this and other slideshows. So that's what this picture is looking at here. And to Bill Mollison's thinking, he's contrasting 3 different farming systems. The top one is what he was calling a contemporary Western sort of monoculture. That means the kind of farming where you remove all of the indigenous plants, maybe plow the soil, prepare it all, go right back to the bare soil and impose what you want onto that system and produce maybe a single crop output, a monoculture. And this is how typified the Green Revolution and the use of tractors and machinery and irrigation and increasingly fertilizer and pesticides to be able to maintain these types of system. What Bill Mollison is kind of proposing in the permaculture system is something that's much more naturalistic, something that looks much more like the bottom picture, where we've got mixtures of trees, pasture and forest, and it's imagining a system which is much more based on foraging, on allowing animals to move around, much more like they would in the wild. And then in the middle picture, he's kind of saying, he's admitting that obviously we can't go from, even if we wanted to move from one system to the other, we'd have to understand what would be the stepping stones in between that might move us from these rather degraded monoculture systems and get us back to something that was what we might call a polyculture, opposite of a monoculture, one with many different elements in it. Hi, Nicholas. Welcome, everyone. We're just getting started, so don't worry if you feel you've missed anything. Yeah, okay. So,
Steve,
yes,
could I interrupt just a little bit?
please, yes.
Just briefly, I realized I logged into the wrong account for the live, and that's why you're not able to see it. Is it okay?
Oh, okay.
No.
Oh, what, for Facebook?
Yeah.
All right. So, well, I'll ignore it now because this is going to just distract me, but
Okay.
yeah. And without, oops. Okay, that's the thing. So this is our little introduction, really. It's about permaculture ethics, about how we dealing with constant change and trying to respond to that, but respond to those challenges within the ethics of permaculture. And that's the journey that we're on. We're thinking about how we can meet our own needs whilst caring for other people and operating within the limitations, the realities of this natural system that we're part of. We're inspired by the work of Bill Mollison, and Bill is telling us to let nature be our teacher and to work with our understanding of nature by observing and working with it. And Bill also tells us that we can always solve problems because problems are actually just the inverse. The solution is just the inverse of that problem. Now, that might take some time and thinking and understanding to get to that level of understanding, but we're encouraged to think in that way. Bill also reminds us that we're trying not to solve problems by using lots of resources. We're trying to solve problems with design, with a change of thinking. So what's the smallest impact we can make to create the biggest effect? Bill also reminds us that the yield of a system is theoretically unlimited. So what we might be able to achieve through using these ideas by collaborating together, who knows where it might take us. But what we do know is if we don't begin this journey, then it doesn't happen. So this is where we're at, and this is our start point for permaculture. Okay. So I'm going to jump into another presentation which is one I've been, which yeah, I've been building for some years and thinking about. And I have recorded this on video, but I'm going to go through it with you live now. And please, any questions or anything you've got, you can put your hand up and interact. Otherwise, Bill Mollison said that we can learn from nature, and that we will get all sorts of different insights about the nature of our world by learning from nature. And David Holmgren, Bill Mollison's student and the other main originator of permaculture, he says permaculture begins with observation. He asks us to observe and interact. So I think that's a really great place for us to be starting, is exactly that, is nature's our teacher. We're going to make observations and begin to think about what it is that we can, what is there to learn about. So permaculture is a design system that links together many different things. So yes, we started with these ethics. We started with these values, and I think that's like our steering mechanism. But we understand also is that the energy that we need, the food that we need, is an interaction between soil, water, climate, that we need food, and shelter. Permaculture brings together, it's a design system for ecological and sustainable living, integrating plants, animals, buildings, people, and communities. So it operates within these ethics. So we're trying to not just do one thing, we're trying to sort of do many things. Or we're trying to understand how this understanding will touch on every area of our lives. So observe and interact. Look at the world around you, and it will teach you things. It will lead you to ask questions. This is a random observation that I made a little while ago, and we're looking at a farmed field here in Wales in the UK, and it doesn't look good. What I'm seeing is soil that's been compressed. It's been compacted because heavy vehicles have driven on it. It looks like a gateway. It's been raining. That soil looks very damaged. And also the soil's now soaked up all that water, so the water's running away. And we can also see the waterfall running down the road, taking the soil away with it. That's erosion. If you are growing food, you're farming, you're looking after a piece of land, and every time it rains, you're losing your soil, you're going to end up with nothing. So one of the first things I think we want to look at when we see around us is what we see is a lot of damage. We see a lot of things that aren't quite right. And sometimes we've seen them so many times before is, we don't really think about it. So when I was looking at this field, I thought, really, this farm has a limited number of seasons it's going to be able to grow food because he's losing his soil. So I'm encouraging you to observe and interact. I'm encouraging you to go out into the community around where you live and spot what are kind of obvious problems. I call this erosion. We've got something which we really need, soil, the fertility, the life in that soil, and through it being badly used, it's breaking down and being lost. There's an example of erosion. Now, in this slideshow, we're going to explore a little bit about how actually nature does the opposite. It does this thing called succession, that natural systems can move from bare rock and build themselves up into being complex forests. Whereas our farming system tends to turn complex systems back to bare rock again. So there's something that we need to learn. There's something that nature is doing that we're not doing. Okay, so I don't know how, this is from the shore. I took this photo on. So life began in the sea. Evolution, you know, there's a lot of evidence for this. But life began in shallow, warm water. So that made me think. I'm looking here at, these are actually, they're called barnacles. They're little crustaceans. They grow on rocks. They're little filter feeders. And inside that little shell, there's a little organism that comes out and filters the water. And it builds its own body. It builds a shell from calcium carbonate. That's dissolved calcium that's in the seawater, and it's taking, and it's interacting with carbon dioxide to build calcium carbonate. And that's the little shell of the barnacle. Okay, so what, you might say? Well, actually, there's lots of little things that live in the sea that have shells, little outside, like exoskeletons, made of calcium carbonate, out of chalk, basically limestone. And these are called diatoms. This is greatly magnified. They're tiny little things, and they're a bit like the miniature version of these barnacles, except for they float around in the water and they eat algae. Now, this is the White Cliffs of Dover. This is the south coast of England. And what you're looking at now is cliffs, and you notice that they're white, these rocks, and they're made out of billions and billions and billions of the dead bodies of these diatoms that would have lived and died for over 100 million years to build up rocks like this. Now, that gives us a little bit of a sense of the life that's gone before us. So all of life on Earth for the first 4 billion years of evolution, all of life was pretty much unicellular, microscopic organisms that lived and died and lived and died, and slowly actually stabilized the atmosphere of the planet. They changed the atmospheric conditions, because you can see here, over 100 million years, that's an awful lot of carbon that's been locked up by those shellfish.
And how is it going?
So I think there's an interesting thing that we can learn as well, which is that, so these are very, very, very simple organisms, but as they live and die, they're changing the nature of the planet. They're changing the nature of the soils and changing the nature of the atmosphere. Life slowly creates the conditions for other forms of life. This is one of the lessons that we learn from nature, and it's amazing. So here's our next little thought. So this is algae. These are very, very simple forms of plant, early forms of plant, that we're looking at, again, under a microscope. This is only 10 nanometers. So that's an absolutely tiny microscopic little thing. And these were the first plants, looked like this. They were unicellular, and they just floated in the water. And they were able to absorb the nutrients that they needed just through the skin of the plant, through its cell membrane. And also you're seeing inside, this is chlorophyll, the green stuff. They're called chloroplasts. They're made of chlorophyll. And chlorophyll is the green stuff. And this is one of the absolute building blocks of life, is plants are able to use the energy of the sun to join together carbon dioxide and water molecules to make sugar. And those sugar represents a stored form of energy. Every other life form, other than some very strange early forms of life, needs to build a relationship with plants to get energy. So again, one of our lessons from nature from very early on is nothing exists in isolation. Everything exists by building relationships with other organisms, and generally that means building a relationship to plants so that we may get energy. So as you can see, these early relatives of plants, relations to plants, is they don't have any roots. And obviously that's because they're floating in water. So it's interesting to think about, how did plants move onto land? What was that process about? And this is, to me, super interesting. This is a lichen. So the first kinds of plants were very simple things, and what we're looking here is a crustose lichen. It almost looks like it's painted on, doesn't it? It's and a lichen is a very simple, very early on down the evolutionary timeline, a very simple organism, and one of the very first organisms to live on land. And it's neither a plant nor an animal or a fungi. It's a mixture of both. So here we are looking at a slide, a microscopic slide of an algae. And what we see is, so look here, so here are these little cells, these photosynthetic cells made of chlorophyll. These are the algae, but they're within the structure of the fungi. So actually what we're looking at is a symbiotic organism that, in order for life to adapt to new conditions, for life to move from the water to the land, what happened was that different organisms fused together so that they had a combination of abilities, if you like. The fungi protects the algae, and obviously the algae generates the sugar that feeds the fungi, and the fungi can access minerals, and which was useful to the algae, and obviously the algae provides the energy back to the lichen. So this is fascinating. So just think, look at this. This is a church wall in England. I took this a few years ago. You can see a bunch of different kinds of lichens growing on the wall. This one looks very healthy. You can see where it's expanding outwards on the edges, and it looks like the fungal part is expanding, and then the algae can grow into that. And what's happening is this, the lichen, this composite symbiotic organism, it can join carbon dioxide molecules together, CO2 to CO2, which creates oxalic acid. And that acid it can use to dissolve actually into the rock face, cause little cracks and fissures, and pull out those minerals, which it's using to build its own body. So in the process of its living and dying, this lichen is slowly beginning a process of building soil. So we're seeing in some ways a process of enablement, where these tough, very hardy organisms can move into these very difficult, challenging environments and start to grow and develop. That's the beginning of the process of succession. And what we're interested in is firstly understanding these pioneer species that start off a process that might begin with bare rock, but carry on moving until literally it becomes a rainforest. Now, it might take quite a lot of time to get there, but the point is that that process has begun. And we could regard this lichen as a pioneer species. Now, I like to think about permaculture in the abstract as well. And I want to think about yourself. Here you are studying this subject, permaculture, new ideas. You're thinking about bringing change into your communities, facing challenges, resolving problems. Well, that makes you kind of a pioneer, doesn't it? And it's interesting to think about ourselves as pioneers. We just by committing ourselves to an idea or committing ourselves to permaculture ethics, we're already starting to create a process of change. And that's the journey that we're inviting ourselves on. And it might not look very promising right at the beginning here, a little smudge of green growing on a bare rock. But very quickly, that process carries on and enables itself to grow. So let's have a look at the next step. We thought about the organic nature of even the rocks of the landscape, and how those processes would have actually changed the atmosphere as they formed. We thought about these unicellular, really simple forms of life, and we thought about how these simple forms of life actually have managed to join together and create composite organisms that can now begin to move into and adapt to new living situations. And what we're seeing here is a moss. And actually this moss was growing just below where these lichens were growing. And what I was thinking, what I was observing when I was looking at this was, I was imagining how over the years, these lichens, they live and die. They grow, they pull bits of particles of rock, minerals out of the rock surface, and they hold a bit more moisture. And then also when they've completed their cycle, they fall away and they're washed downwards. And that organic matter then becomes like the humus. It becomes the beginning then of a very simple soil. And here we can see, look, this moss is growing, and it's more three-dimensional than the lichen. It's got lots of little strands of like little hairs on it. It can hold more water. It can provide habitat to more microscopic organisms. And in that process, as things live and die, it's now accelerating the next stage of the succession of soil building. So again, think about the steps between those first pioneering people or ideas, and then the next steps in which you first begin, if you like, in a very small and unambitious way, but start to build something. And then how the next layer of this is called a sphagnum moss. It has much more longer fronds. It has many more spines to it. It can hold a lot more water. You can slide your hands deep inside it and feel the cool and moisture inside, and think about how many other microscopic organisms and little microarthropods and things might be living in there. So we're moving slowly from bare rock to something slightly moist to something a bit more three-dimensional, much more like a habitat. And maybe it's essential to understand that to move from a very degraded or damaged or bare environment to something more complex, we actually have to go through these stages. We can't sort of leapfrog it, which is why sometimes if you just take trees, plant them out in the bare rock or something, they're not going to establish. You have to create the conditions for them. I'm getting ahead of myself though. These are very early ideas in permaculture. So here's another thought, and I talked about succession. Okay, forgive me if this picture looks a bit as a temperate landscape. We'll be looking at examples of things that look a bit more like Africa as well. But remember, we're looking at the patterns. The details will always be different, but we're trying to understand the general pattern. So, I mean, back really to my first slide, which is nature does not like bare soil. Think about this. Soil formed under trees, soil formed under long-term vegetation, grassland, but something that was there long-term. And think about how multiple generation, year after year, plants living and dying, contributing organic matter, which becomes part of the soil and which becomes part of the soil microbiome of these microbes and fungi and other organisms that live in the soil. So as soon as soil is bare, it doesn't have any plants on it, or it's not covered with either living plants or perhaps with a matter of dead plants, then it's going to dry out in the sun. It's going to get washed away by the rain. It's going to become compacted, which means it's harder for it to absorb water. So actually, one of our first lessons from observing nature is, as soon as we create bare soil, plants will try and germinate in it to begin the process of succession. What we might call weeds, plants that grow very, very quickly, that germinate quickly, reach seed quickly, and then die quickly. Those are the first things that are triggered when there is bare soil. So succession is often triggered by, okay, this is something which I like to make people stop and think about for a moment, is if we imagine a natural system, a wild system, a forest, a steppe, the scrub, but without humans. How might it come about that in that circumstance you would find bare soil? If we would just have a wild natural system doing its own thing, how would it come about that we'd end up with bare soil? Because otherwise it's going to be covered by plants, isn't it? Well, of course, there might be a flood. There might be a seasonal flood, plants might get washed away. Sure, that happens. There might be a fire. Fire would quickly remove the plants, wouldn't it? An animal might dig a burrow. That would create some bare soil. There might be a landslide. It might be a pathway, something like that. But actually, all of those things that I've mentioned they're fairly catastrophic. Flood, fire, landslide, animal digging. And they don't happen all the time. They would only happen very occasionally. So even if that were to happen, the landscape is sort of, the combination of plants in a wild landscape are there to be able to grow back quickly and to be able to cover that soil and protect it. So we might also, if we go to the next slide, we can also see that there's a kind of a time element, is that there are things that live just a few months that might, weeds, fast growing, fast carbon pathways, things that can germinate and protect soil come first, and they might have quite a short lifespan. They might give away to grasses and to other herbaceous plants, which maybe have a bit more biomass and live a bit longer, put down deeper roots, and that create the possibility of soil building and more, longer term things happening. And obviously, you can see now the soil is being protected and shaded. We move maybe into shrubs, woody plants, young trees, maybe get pioneering. and then they might be they might be replaced then by faster growing trees, which maybe have longer life cycles, but then slowly they're replaced by the canopy, the final sort of canopy trees that then have the longest life cycle. So think about how things might move through from bare soil through perennial plants and grasses, shrubs, fast growing trees to longer growing trees. That's what nature wants to do by itself. So as permaculture people, as permaculture designers, what we're challenging ourselves to do is to understand that that's what nature wants to do. Understand that that's the natural direction. So if we work with that, then we'll quickly gain, this complexity of structure. Look how we move through the timeline where there's very little biomass here. There's not much going on. There's really not much going on. Whereas much deeper into the system, it's much more three-dimensional. It's much more surface area. There's space for all sorts of many different kinds of species to live at different levels, all sort of folded in within the ecosystem as it develops. So as farmers and as growers, we've become very reliant and very focused on these plants that come at the beginning of the succession, that the things that really weeds and grasses and many of our food plants kind of fit into that category. And whereas what we learn when we look at nature is when we get further into the succession, where we have plants living longer periods of time, we have the opportunity for much more biomass, for much more habitat, for much more solar capture. Because don't forget, these plants are catching and storing the energy of the sun, turning it into sugars and carbohydrates. So the more plants we have, the more dimension there is to that, then the more energy we're catching, the more productive our system becomes. So very early on in permaculture, Bill Mollison and David Holmgren became very interested in the idea of food forests. And that's sort of where the idea began to come from, was the realization that as a system matures, as we move from the bare ground to the forest, the system kind of speeds up and then slows down. Its ability to capture that solar energy increases and increases up to a certain point, and then it starts to slow down again as we reach a more of a canopy situation. So a young woodland turns out to be one of the most productive systems. So can we make our farms look more like a young woodland? These are just opening thoughts. There's a long way to go with this, but what we're seeing is certain patterns that we can see when we look at nature, and we realize that these processes have been going on around us for millions of years, and all it takes for us is to sort of scratch the surface, ask a few questions, and we begin to get a sense of a slightly, a more harmonious way of understanding. And remind what Bill Mollison said was, work with nature, don't fight against it. So if we want to keep at the beginning of the succession, so we have bare soil, so we can plant, annual grasses and short growth crops all the time, then we're actually fighting against the whole of this succession. We're trying to stop all of these trees, the birds, the animals, the insects, everything that might live in this system. We're trying to exclude them all and go back to bare soil. So, look, there's nothing wrong with growing annual grasses and vegetables, but if that's all we do, then we're actually only achieving a very small percentage of what's possible. So our big lesson is understanding this process of succession and how nature becomes more productive, more complex as these systems develop. Okay. So those are some opening thoughts and thinking about succession. Now, we also just talked about this carbon cycle. I want to get back to a little bit the idea, because what I've said is, look, over time, life stacks away carbon. There it is, calcium carbonate. There's carbon being stacked away by life. And in this wood, this forest, these trees are made from carbon. The shrubs are made from carbon. As they live and die, that carbon ends up in the soil. We get a more carbon-rich soil as well. So we're going to think now a little bit about the carbon cycle. And to understand that, some of these elements, essential elements, components of these natural systems, is they're constantly moving around, and I think we need to understand that a little bit, because that's one of the key things we learn when we observe nature, is everything's cyclical. Everything in some ways cycles. Okay, so here we are with a very simplified model of the world. So again, remember, permaculture, it moves from patterns to detail. We're very much at the wider pattern stage. We're understanding the key principles that underpin the world that we live in. And for me, it seems important that everyone has at least an understanding of this, so that we know, we can agree in the long term about what we're doing. Okay, so this is why I'm laboring these points. Let's just look at the forest bit in the middle. So vegetation and land. So what happens over time? You can imagine these trees, this forest is growing. There's lots of other things within a forest than the trees, and those trees are essentially made from carbon. And plants photosynthesize. That means that they use the energy of sun to join carbon dioxide, CO2, and water, H2O, together, which is sugars. Sugars linked together become starches and carbohydrates, and then essentially that's what the tree's made out of. And that's the energy that's flowing through the tree is the sugars. So as we go through the year, so these figures are actually from the 1990s, so they're a little bit out of date, but the principle is the same. So over land, approximately 450 billion tons of carbon dioxide are drawn down every year by the plants that grow on the land. And a lot of that, as these plants are growing, they're also dying, shedding leaves and twigs. They're also being eaten by caterpillars and beetles and birds and what have you. So as much as it's pulling down this large amount of carbon dioxide, 450 billion tons a year, also as forests live and die and degrade and are eaten, that a lot of that energy, a lot of that carbon is also returned to the atmosphere, approximately 440 billion tons. So what we can see here is actually over the landscape and vegetation of the planet, there's a net drawdown, we could say sequestration. There's a net drawdown, a stacking away of carbon each year of about 6 billion tons. Okay, and that in turn, is what the forest is made out of, and then ultimately it's what the forest soils become made out of. Okay, we have a similar picture for the oceans, and we can see that there's lots of life. There's algae and diatoms and things that eat those algae, and obviously fish and everything else. Big aquatic ecosystem in the sea, in the oceans, and that is responsible for drawing down 338 billion tons of carbon a year, figures from the 1990s. And again, similar sort of proportion is most of that is returned to the atmosphere, but there's a net sequestration of 6 billion tons per year, okay, of carbon that's going into the ocean. So we can see there's 6 on land, 6 on sea. That's about 12 billion tons a year of carbon, which is sucked in and incorporated into the soils and to the organic rocks of the planet. Now, of course, what happened is back 1750, we humans discovered how to build a blast furnace, and we started the Industrial Revolution, not very far from where I'm currently living, and began burning firstly coal and then latterly gas and oil to drive industrial processes. And obviously that coal, gas and oil represents organic carbon that's built up in the crust of the earth over millions of years. And by burning it, what human activity is now doing is adding carbon to the atmosphere. And the figures back in the 1990s was 23 billion tons a year. But I can tell you now we're at 40 billion tons a year. So this picture's getting worse all the time. And unfortunately, what's happening is that human activity is creating an imbalance in the planet. And so the atmosphere of the planet, which was created by the life on Earth, is now being changed because humans are burning fossil fuel like as fast as they can. And we're cutting down the forests and we're disturbing the soils. And then unfortunately, as the oceans become more acidic, their ability to absorb carbon dioxide is also reduced. So this one slide really is the big picture for the climate problem. And what we need to understand is that we're at a point in time where the world has to move away from fossil fuel burning. We've got to not become ever more reliant on that. We need to move away from it. We need to farm in a way in which, instead of returning all of this carbon to the atmosphere, we can actually farm in a way which stacks away much more carbon. And that's one of the key themes that we'll be following through the PDC, is why we want to do that, how we might do that, and to work with those techniques to our benefit. Okay, so, and we'll think more about how we work with aquatic systems as well. So that's the big picture of the carbon cycle, and what it's saying is every year the natural world is stacking away carbon, but humans are returning that to the atmosphere faster than nature can do that. So we have to end that situation. And as permaculture designers, we are on the leading edge of finding more ways to farm, manage the land that stack away more carbon. Okay, so without getting into too much detail, let's just think about the movement of carbon from the atmosphere deep into the soil. We might call that process translocation. The translocation of carbon from the atmosphere deep into the soil. So the first thing, we just have a little look at this picture, is there's our tree happily photosynthesizing. It's drawing in CO2 and giving off oxygen, of course. And let's also just say that as we go deeper into the soil, is the characteristics of the soil changes as we go deeper down. Now, again, there's variation in soils in temperate climates where I am and tropical climates where you are. So we'll look into that in more detail. But again, the sort of general pattern is the same. So as we go deeper into the soil, we might cross different horizons, and that the O horizon, which is the surface layer, that's where There's a lot of oxygen, there's a lot of organic matter, or also microbes, and lots of interactions between those elements and the roots of the trees, and so forth. Most of the life in the soil biota, the microbes living in the soil, the beneficial ones that we're interested in, they're just like us, as in they breathe in oxygen and they breathe out CO2. They are aerobic. And here we can say, look, there's CO2 coming from the soil, going back to the atmosphere from the respiration, the oxidizing, using energy of the soil microbial population. So some of the carbon in the soil it's leaving back to the air, but some of it is slowly moving down deeper into the A and the B, the C horizons, the deeper, more stable areas of the soil where there's less change, less interactions. You can imagine how the roots of a tree might grow down, and as the deeper they get, and as they live and die, they leave behind carbon deeper down into the soil. Think about the actions of worms, other burrowing creatures. Think about how slowly, some of that carbon is going to move deeper down into the soil. And as it does so, it becomes more stable and it stays there longer. This is what we're actually interested in achieving in the longer term. It's the translocation of carbon to deeper down into the soil. And as farmers, what we learn is the more we can achieve that, the more fertile our soil becomes. The more the soil is able to hold water, absorb and allow rainwater to sink in. And also the more the soil can remain aerobic and it can favor those organisms that live in the surface or the O horizon of the soil. These are all things that we want to do. So permaculture techniques are good for the planet, long-term, climate change, those kind of things, but they're good for you and they're good for your individual garden as well. So this is where we kind of have this idea about think global, act local, have an awareness of the impact that we're having on the planet as large or on our bigger systems, but then understanding that by paying attention to what we're doing locally, we can have this a very beneficial effect. And so this is something which we're very, very interested in permaculture, is how widely can we spread this? How many people can we involve in this way of thinking and behaving? Because this could create a very big and very beneficial change in the wider world, something for all of us. So we can look at this in different ways, and I don't want to get you too bogged down in the details, but look, this is saying the same picture, really, the same process. Here's carbon dioxide in the atmosphere. It's being drawn down by the trees, it becomes part of the vegetation. It's used in photosynthesis. Some of it's returned to the atmosphere as the tree respires. Some of it is just as the organic residues of the tree, of the leaves, and the caterpillars eating the tree and what have you, as they live and die. Obviously, that carbon is also returns to the atmosphere. As animals graze and eat, and they respire, obviously that carbon dioxide is returned to the atmosphere. Some of it stays around for a long time. Some of it stays in the soils. And on the previous slide, we talked about translocation. It's the deeper down into the soil it becomes, it arrives, the longer it will stay. And of course, the other side of this picture is we're building our buildings out of carbon. We're cutting trees down and making them into houses and barns, and we're digging up the coal, gas, and oil and burning that as fuels and as pesticides and so forth. And so obviously we're accelerating the carbon return part of this cycle at the same time. But what's important to realize is we're never going to run out of carbon. There's enormous amounts stored in the ground, and once it's been becomes part of the atmosphere again. It then becomes available for plants to draw it down again. So this, again, idea of cycling. We're not running out of resources. We are cycling resources. And when we think about things that way, we realize that we're not going to run out. We don't have to be scared of scarcity. There's plenty enough. So actually, you can look at the carbon cycle on a very long term as well, because when there's interesting geological features that like volcanoes is, well, carbon dioxide comes out of volcanoes as well. And it's a fair question to ask, well, where did that carbon come from? So again, look, we've looked at this in a sort of a general simple system. We've tried to think of it a little bit in detail, look at it on a kind of farm scale. Here's the carbon cycle on a kind of planetary scale. So here's still our photosynthesis, trees living and dying, and some of that carbon ends up as soils and peat and coal and other carbon-rich deposits, which ultimately become part of the crust of the earth. And here, in the yellow here, this is the calcium carbonate. That's the limestone and the chalk that we saw at the beginning. And perhaps it's perhaps important to note and to remember is what this picture is also showing is our continents and the seabed are actually floating on the mantle of the earth. And there are times when one plate comes against another, so one will slide on top and the other goes underneath. So the one going underneath, that's called subduction. And so the plate that's underneath, that's being back into the mantle of the earth, then melts and is reincorporated, becomes molten again. And that's when any organic carbon trapped in that tectonic plate then expands in the heat and forms cracks and then escapes out through volcanoes. So ultimately, the carbon on the seabed gets subducted back into the crust of the earth, comes out through volcanoes, and ultimately is available then for photosynthesis again over millions of years. So we've got a carbon cycle maybe happening within a day, within a week, within a year, and then other carbon cycles happening over very long periods of time. So all of that is interesting to note, okay? And it sets a sort of a wider picture for us to think about. So I'm gonna, there's some opening thoughts around the carbon cycle, and in the context of how do we learn to work with nature? How do we understand the processes going around us so that the little individual things that we're doing fits into a much bigger picture? So we have coordinated action that benefits the whole system. Okay, I'm going to take a little break there, just have a pause. And any thoughts or feedback or questions from anyone? Just tell me how you're following this and how you're understanding it. Hello there, Simon.
Yes, sir.
Yes, how are you following the lecture?
Sir. The lecture is good. Now, for the question here, sir.
Yeah.
You can talk to Abadan, yes?
Yep.
How can one improve on carbon when it is lost from the soil? That is one question.
Yep. Good question.
Then question two, what are the signs and the symptoms of carbon life loss in the soil? Thank you.
Okay. Well, we will answer your questions in a lot more detail as we progress on the course. And
Okay.
within permaculture, there's many techniques that we might use to address these things. So I'm going to give you some simple answers. Is if we can keep soil covered, the more we can keep soil covered, the more, which means shaded from the sun, either with living plants or with dead matter, then the carbon in the soil is less likely to be oxidized, to be burned off in the sun. We can add carbon to the soil by using techniques such as green manures, compost manure, and also biochar. So there's many techniques which we can begin, and the thing that will be encouraging everyone to think about from the beginning is making compost. That's one of the building blocks, and one of the most important practical things we can do. And so principle 1 in permaculture of these 12 principles is observe and interact. So I challenge you to observe and look around you in your community. Is where is there carbon that you might use? And it could be anything. So anything that has lived before will be largely made out of carbon. So dry grasses, animal manures, the shells from maize plants and cobs and nuts, the chaff from rice. All of these things are forms of carbon. And I'm going to be asking you to begin to value those. Understand that these are elements you can use in your compost systems and for rebuilding your soils. So that's as much as I'll say for now, but we're going to enlarge on all of those topics. Anyone else? Nicholas, would you like to share with us any thoughts, or anyone? If you just unmute, we'd love to hear from you. Are you able to follow us, Nicholas?
Okay, thank you, sir. Okay, I'm very happy, and I would like to thank you. What I've come out with by the time you are teaching, now I know the importance of observing and interacting in my community. So from today, I'll walk around and observe the kind of soil we are having, the kind of my family, the community members, and I'll come up with the many ideas and solutions. Thank you.
That's great. That's a really good starting point, and you're learning the lesson. Anything that people think is waste or they're throwing away we're going to challenge that and see how we might be able to see that as a resource. Okay, anyone else? Joseph. Thank you, Nicholas. That was really good. Joseph, are you hearing us? Okay. Maybe not. Maybe he's not able to reply. Deborah, are you there?
Yes, I'm there.
Good. Are you hearing us okay?
Yes, please.
Okay. Thank you.
But
Yes, sorry, Deborah. Go ahead.
yes, please. I wanted also to add on the principle number 1.
Please.
observe and interact. It says beauty is on the eye of the beholder. This principle, you observe and interact around your family, the community, how your soils look like, what type of carbon, what type of compost, what type of liquid manure or natural pesticide do you prefer to make to change on soil fertility? This means it involves seeing nature patterns and cycles. I understand, observe, and interact as a solution-based, not problem creator. Okay? That's how I look at it. This principle, number 1, observe and interact.
Thank you, Deborah. That's really good.
So when you
there's a lot of layers to this, isn't it? So when it says beauty is in the eye of the beholder, what that means is that actually we all see things slightly differently because we've had different experiences. And we're reminded that observation is also subjective. So your observations might be slightly different from someone else's, and we're encouraged to understand that and to accept a perspective from different people. I always give an example that, you know, if I was to give you a big bag of cow manure, some people might be disgusted by that and think how horrible it is and smell and flies and maybe disease. And for someone else, they'd go, oh, I can make compost. So, yeah, beauty is in the eye of the beholder.
Yes, that's how I understand, observe and interact. Sometimes when you want to observe how your land looks like, it helps you to measure the level by the use of A-frame.
Yeah, sure. We will. We will definitely enlarge on that under our design tools, Deborah. But you're so right though, is to begin to observe your land in detail and kind of asking fundamental questions. I can see Simon has his hand up. Is that a question from you, Simon? Please.
Yes. A question from Simon. Okay.
Yes. Hello. So now here you talked of carbon, but when a plant loses carbon, what are some of its signs and symptoms?
Okay. Well, one of the signs of one of the rules which we try to give, we try to advise people is don't stand on your soil. So when we're in a growing area, we make a path and we make a bed. And one of the reasons that we're doing that is because we understand that the life in the soil breathes air, just like we do. And that if we stand on the soil and compact it, then there's less air, which means there's less life, there's less activity. And one of the things that's going to bring carbon into your soil is the soil life. So the first thing we do is, and we'll show you this, we have many examples of this, we deliberately make raised beds and pathways. So we build up the topsoil and we don't ever stand on it. And then we cover it either with dead material like old leaves and grasses, which also help protect the soil and stop it from drying out. But the other thing we do is we make compost, and then we add that compost to the soil, and then slowly, that also builds up the carbon. So if your soil is low in carbon, you can tell because it's very hard and compacted, and there's not much air in it. And when you smell the soil, you don't smell that soil smell, that fresh soil smell. And it also won't be able to hold water very well. Deborah, would you like to add anything to that? You have a lot of experience there. Thank you.
Sometimes and also planting.
Oh, maybe try turning your camera off. We're not quite hearing you. Okay, try again. We might hear you. It's better.
Wanted also to add what Simon was asking about carbon. When we want to store carbon, sometimes we can plant cover crops also. Even mulching can help us to store carbon, because when you mulch your soil, you will find that it contains moisture to the soil, and the soil remains moisture. That's what I wanted to add on the question of Simon about carbon.
Thank you, Deborah. That's a very good observation. So I used the term green manure, and you said cover crops. So yes, we have to check. I meant the same, but it's very good to reiterate, and we can't make a point too many times. I think so. I thank you for clarifying that, and you're very correct about mulching and covering the soil with dead organic matter, which some of which will also become included into the soil. So you'll see many pictures of and examples of these techniques, Simon, and but you're asking a really good question, and what we want is for people to understand why we do these things, and that's obviously the key point. Okay, so unless anyone else has a question, I'm going to carry on. And I'm just aware that at 6:30 we might have some people joining us from UK, or maybe not.
Well, Steve, I just wanted to supplement.
Please.
About I just wanted to supplement about the ground cover plants, the likes of creeping or vines. They are also good for storing carbon. So, meaning if you have willow plants, like those creeping plants, or vine plants, the likes of gourds, the likes of pumpkins, the likes of squash, then the likes of, in Uganda, we have what we call gourds, bottle gourds. They are also good. Then we also have passion fruits. They are also good for that purpose. And even we have also the creeping thyme, which is also good. And I can understand, I don't know where the question, I don't know who asked the question very well, where he comes from, but when you go to Kumi, we saw that creeping plant, which is there at that place where we used to stay. It was there. Yes, thank you very much.
Thank you, Ali, and thank you, anyone. You're welcome to, contribute to these ideas as we discuss them. And again, what's kind of interesting is that even if we're in different climate zones and maybe we have different plants available, we're still actually we're still following the same patterns and processes. That's the key thing. So actually, the same kind of things happen in different climates and with different plants, and what we're trying to do is to understand the processes. We can see it and understand it in a more general way. Okay, that's good. Thank you for that, Ali. So yeah, we're learning from nature. Oops. Oh, this is good. And I've touched on how oops. Sorry. Why it's not doing? Sorry, I got a problem. Oh. Oh, okay. All right. Sorry, folks. Just have. Sorry, I was playing with this earlier, and I understand now what I did. Okay. I'll make a switch. Go back to this one, which is what we had, what I started with, and I've based these slides. So we've just been making some observations of nature, and we've thought about. So if we go back to this first slideshow, and these are pictures from Bill Mollison's book, this is the situation that I'm describing, is how through intensive monocultures we've simplified the natural world, and that it so turns out that having much more carbon-rich systems with many more trees actually help build soil, they help shade the soil, and they create habitat for other organisms. So maybe we're beginning to understand how the benefits, if you like, of taking a different approach. Because what's happened over time is the whole landscapes are now starting to dry out, and we're starting to lose the biodiversity that is part of natural systems. So that's what we're now having to go against, to re-find our balance. Now I want to make it. Oops. I want to get back into this. It's. Oh. Oh, there we go. Got it. Sorry about that. Got it now. Share screen. Sorry, folks. So I'm going to sort of go into thinking about the importance of forests and in that it's nature left to its own devices. If nobody does anything, it does this. I think this picture to me tells so many things. So a picture can tell 1,000 words. This is a boat. It looks like a barge, and it's sunk in a river. I think this is in Africa somewhere. I don't know exactly where. And what we've seen is, I don't know how long this has taken, but this old boat, this old barge has been completely colonized by nature. No one has I'm getting phone calls. Nobody planted anything. Nobody bought anything. Nobody's done anything. It's well, we might ask ourselves the question: how did those plants get there? What was the process that made that happen? Okay. Sorry. I need to turn my phone off, don't I? So I have very elderly parents who right, sorry about that. Okay. Let's just think about this. That natural forces can self-assemble complex, three-dimensional, interconnected ecosystem all by itself. That's what I mean by succession. But when that boat originally sank there was no soil, there was nothing. And what happened, what we can only guess happened is on the wind, little seeds blew in, maybe bird droppings, maybe some other creatures arrived there and left behind seeds, left behind what became the pioneer plants, the pioneer elements that lived and died, created some humus, created some fertile soil, that let other seeds germinate in, and slowly, it's evolved into a forest. So as farmers, as gardeners, as custodians of nature, we can understand that actually we don't have to do anything. Nature wants to do this all by itself. Our challenge or our opportunity as permaculture designers is to ask ourselves, okay, so nature wants to do this. It wants to move from bare ground to forest. How do we speed that up? How can we help that process along? How can we make interventions so we steer that to a system that actually includes things that we want? Can we incorporate into it our own food plants or other things that we need? So that's there's the holy grail, if you like, that we have to dream about in permaculture, is a food forest that grows all by itself, self-assembles. Maybe all we ever have to do is to pick the fruits, to harvest from it. That's the potential. And also remember, Bill Mollison told us the yield of the system is theoretically unlimited. So who knows how far this could go? Just the fact that it looks like this doesn't stop it from evolving into something, even grander and even more complex. So again, there's an observation of nature. Somebody saw that, took a photo, put it on the internet. I saw the photo, and that's, for me, started off a whole chain of thoughts about, working with these. This is what we mean by working with nature. This is what Bill Mollison's really saying. There's no fertilizers, there's no special seeds, there's no GMOs, there's no pesticides. It's organized itself. So, and we can call that random assembly as a design process. Is nature just, things have just blown in on the wind, random bird droppings, or etc., and then that whole system then has become a living thing of its own. And then think about, as it grows, how now it's capturing so much more solar energy, holding more moisture, and increasing the potential of the system. So the ultimately, the final yield is unlimited. Okay, so now let's just imagine and understand what those stepping stones of that system might have looked like. Okay, that's a tropical example. And this next slide is, I took this photo. I was waiting, I've been at work, and I was waiting in the car park for someone to come and give me a lift at the end of the day. And I noticed that although the car park looked like it was flat, it just tilted off to one side, and there was one corner that was moister, and it was where the moisture must go. And in that corner, there was just a carpet of moss. And this is growing on top of tarmac, on top of concrete. And yet here we are, there's this living layer of the moss, and actually it's covered. You can see these little brown dots. What these dots are birch tree seeds. And birch trees are pioneer trees. They look a bit like this. They grow in much colder climes. You see them a lot as you go much further north. It's a kind of a tree. This is a silver birch. You can see the silvery bark. It grows quite quickly, and then it dies quite quickly. It doesn't live that long, and when it does fall over and die, the wood's very soft and it rots very quickly. So in that process, a tree grows, helps build soil, and then dies and decays, and then contributes to long-term soil building. So you can see here, this is in Wales, this is in a river estuary in Wales, and you can see the huge area of land that's been sort of consumed by the regrowth of this birch. And what I thought when I was looking at this was, if you compare the first photo to the second, is the plant's really doing the same thing, that you've got a complete sort of carpet of moss covering that bit of ground, but it's only a few millimeters tall, but it's still doing that. Whereas here, these trees maybe 30 or 40 feet tall, and they're carpeting the ground as well, but they're doing it at a bigger scale, and that compare how much water and how much organic matter the moss can hold, and then think about how much more this mature pioneer young woodland can store. And don't just see it as a woodland or as trees. Think about, think of it, you could see it as a lake. Think about how much water is trapped within that system. And the more water there is, the more potential there is for life. So, and again, we're still talking about succession, this idea about nature sort of creating the conditions for the next thing to come along. And as we get a bit further into the permaculture concept, we'll be also thinking about how we could use this process of succession to further our own farming, gardening, growing, landscape renewal, whether we're doing small scale, local, or large, broad scale. These ideas help inform us and think about what we're doing. Here's an observation I made. This is in a town in England. It's called Reading. I looked through some gates. The gates were locked, and it looks like a car park or something. I don't know, just a piece of ground. But look how it's paved. It's got these kind of bricks on the ground, and no one had been in there. Months and months and months. It looked like it hadn't been used. What do we see? Well, we see succession. We see bare rock, and we're seeing hardy plants. Here's mosses coming in and starting to colonize the space, living and dying, building soil, opening up little cracks, making opportunities for life to come in. Now, But look where the mosses have started. Look where they're actually growing is they're growing in the mortar, in the cracks between the blocks. So we're also getting a little idea of microclimate, that the differences between these, there's a subtle difference between, in the gap between the bricks, where there's a bit more moisture. That's where the succession begins. That's where the mosses take hold, from these little cracks, from these little edges, from fissures. And that, again, is actually giving us an insight as to how nature recolonizes. It's looking for cracks and edges and little things to hold on to, and simple plants will come in. And then look how quickly these taller herbaceous plants, we can see them all, have then flooded in, maybe with opportunities created by the mosses. And then if we look over to the right side of the picture, we can see grasses and more complex herbaceous plants. So you can see that we leave this space for another 2 or 3 years or something, and you're not going to be able to see the bricks anymore. And even the mosses will get pushed out by the grasses, the herbaceous plants, and eventually we end up with trees again. So you can look at random events going on around you, wherever you are, use your observe and interact ideas, ask yourself, what's going on there? What am I, is there something I can learn, or is kind of gain some insight into what nature's doing all by itself, without any input from me, any energy from, or anybody buying anything, feeling that they need to go and buy something. So here's a thought that's something that I derived from observing this system. So we've got rocks, and we've also got this little mortar strip between the bricks, which is a little bit more porous. So, and I saw this picture of a porous pot, a clay pot buried in the ground. It's effectively doing what the gap between the bricks is doing in the picture, and that's allowing water to percolate in more deeply, spread out, and start to nourish the plants, which then allows growth to happen. So just think about how simple observations from nature might give us ideas that we can then translate those ideas into techniques that we're using in our own growing. Okay, so thinking about succession, thinking about how a forest builds itself out of nothing. So the soil formation, the mosses and lichens, water trapment on whatever scale, all of those things start to increase the potential for growth. Now then might move into the succession, other very specialist plants that have particular abilities, and this is a very ancient plant, actually. It's common in the United Kingdom. We call it greater plantain. It's a very low growing plant, and we associate it with growing on pathways and hard compacted ground. It turns out it happens to be one of our most useful medicinal plants. Has many useful characteristics. It's very good at withstanding cuts and grazes and abrasions, and somehow that reflects the kind of tough environment it's able to grow in. And it's one of those plants of the succession that maybe follows on behind the real pioneers and is a low growing, tough, herbaceous plant, which is the next little stepping stone on the succession, that next little kind of plant that's a bit more complex than a moss or a lichen, and creates a different kind of habitat, and also will attract in grazing animals that like to nibble on these kinds of plants. So you can see how one thing then might create the conditions for the next, and sort of stepping stone process. Now you might not know what this plant is. It's called Scotch broom. I photographed this in a woodland in Scotland. But even without knowing what the plant is, and you might not have seen it before, you can recognize it, because you can recognize things about this, because you have plants wherever you might be that have the same patterning as this one. Now I'm referring to these seed pods, and the seed pods rather look like peas or beans. And that's because this plant, Scotch broom, is part of the legume family. And there are certain kinds of plants called legumes which can fix their own nitrogen. So there's plants need lots and lots of different nutrients, but there are three key building blocks that plants need to access to be able to grow, and that's nitrogen, phosphate, and potassium. They need nitrogen for the green leaves, phosphate for root development, and potassium for fruits and flowers. So NPK, they're scientific symbols for those, are the key plant nutrients. And so where there's no nitrogen, then you're not going to get big leafy plants because there's no energy that's if you like, the building material that the plant needs is the nitrogen. And this plant can supply its own nitrogen, and it does it by building a relationship in its roots with a particular bacteria called rhizobium. And the same way as what we saw in the lichen, where there's an exchange of sugars and minerals, in this case, the plant pushes sugars down into its roots, which nourish the bacteria, and then the bacteria supply the plant with nitrogen. So this kind of plant can grow in soils which are very low in fertility. In the process of growing there, they create fertility, they build soil. So this plant and this family of plants is a nitrogen fixing plant, or a legume. And there's many trees, shrubs, and annual plants that have this characteristic. So this is one of the reasons why and how a forest could grow on a ship, because it can actually manufacture its own nutrients through very simple but very important associations between plants, fungi, and bacteria. That's because they're all growing together. And that's what we got from the idea of the lichen, this idea of symbiosis. So important. Okay, so within the succession, we might find that we get lots of fast-growing plants that have fruits. And this is certainly something that I notice here in the UK. This one we call elder. It's a tree. It's a fast-growing, very soft tree. So again, it grows quickly and dies quickly, and it produces a lot of berries. These berries obviously are loved by birds. So wherever there are birds, you will see elder trees coming up. And what's interesting about this, and I'm going to show you a few more examples. This is a rowan. We call this a mountain ash. So this is a young tree, hardy pioneer tree that grows higher up in the mountains in a hardy environment. But again, it has lots of small fruits, which the birds like to eat, which means that the seeds of these plants are everywhere. So going back to the idea of random assembly, nature's peppered itself with the seeds of the plants that start the regeneration, that start the succession. Look, I told you about these birch seeds. Look how small they are. Imagine how far they might carry in the wind or in the droppings of a bird or insect or something that might have eaten it. So the components to build an ecosystem are kind of there already. There are these seeds from these berries. This is a blackberry or bramble, and again, birds love to eat these fruits. The seeds are everywhere, and then they quickly germinate when they have an opportunity. So, actually, what's really wonderful about this? So you'll notice there's this blackberry, the bramble. It has big spines on it. It's very spiky, and it's a trailing kind of shrubby plant. And what it does is it grows up into the sun, and then it's not strong enough to stand up like a tree, and it falls over. and where it touches the ground, it roots and then grows up again. So it kind of bounces its way out like that, and then it sends off side shoots. So you end up with a thicket that's all thorns and fruits, and it's a right mess. What that does is it creates an environment that pushes out the grazing animals and browsing animals, things like deer, sheep, or cattle. They get pushed away from these thorny plants, and underneath the brambles, you then get areas where trees start to germinate. So here's the thing, is plants like these nitrogen-fixing plants can create fertility by teaming up with bacteria that pull nitrogen out of the air. Now, you need to, if you know that, you know then that you don't need to buy nitrogen fertilizers, because there are plants that can do it for you for free. That birds, when they come and eat their fruits and they give off their droppings, that bird droppings are rich in phosphorus. So we've got that. Nitrogen comes from the nitrogen fixing plants. Phosphorus then starts cycling around, and birds are eating fruit and insects, both of which are high in phosphorus. And as that phosphorus cycles into the ecosystem, it becomes available to the plants can develop more complex roots, and you get more complex plants then entering the system. So, life creating life. And look at this, of course, again, is you start getting fungi entering the system. This is a bracket fungus, and it's digesting an old wood stump, an old tree stump, and we can see lots of mosses growing there as well. And thinking about how, as this little forest system develops, it's including elements which are also helping it digest the dead stuff and build the soil and feed the other living components. So again, every element within our little woodland is starting to help build the whole, contribute to the wider whole. This is a young woodland up in the north of England. I took this photo some years ago. And what we're seeing is, as these young trees are getting started, is the forest floor is flooded with a plant which we call bracken. It's quite a tough, hardy plant, grows from a rhizome just under the surface of the soil. And it is a forest plant, but as the trees grow and develop, it's shaded out. And obviously, you can imagine the trees grow and they become more leaf cover. The forest floor becomes darker, and so this bracken will be kind of pushed out, so just be in little clearings or just the odd individual plant. Should a big tree come down, cause create bare soil, create a big hole in the forest system, then the bracken will flood in and grow there quickly and protect the soil. So what's interesting about this plant is it hyper accumulates, it draws together and contains potassium. So that NPK, the key nutrients needed by plants to grow, nitrogen, phosphorus, and potassium. That there are plants themselves which either create or join together and hold on to and accumulate those key nutrients. So this is how plants assemble their own ecosystems. And this is how, as gardeners, growers, farmers, habitat restorers, this is what I mean by observing from nature and understanding that we can actually use the materials that are there already and work with them and build the system that we need. And as we build it, we can obviously steer it so it produces whatever it is we want it to do. Because if we are the designer, we can then anticipate what we want the outputs to be and build that into our development process. So you can imagine as our woodland develops, it might get more complex, and we might see something like climbers, vines coming in, climb up the trees, harvest sunlight from in this kind of opportunistic way, three-dimensional way. making the system more efficient. As each one of these elements is adding into the forest system, it's adding another angle, another dynamic, another yield. And as I said, the yield of a system is theoretically unlimited. And we're seeing here now how the presence of one organism maybe creates the opportunity for another. So here the tree, this vine is climbing up the tree, whereas before it'd just be on the ground, right? But now it has the opportunity to achieve much more, create more surface area, catch more energy of the sun, create more biomass, make more sugar, increase the overall yield of the system. Okay, so these are lessons which we get from observing nature, from watching the development of a bit of bare land, maybe through succession to become a more complex established woodland. And these things are happening around us all the time. None of these photos I've taken are particularly special. I just kind of try and keep my mind open as I'm walking around, and I look for things that help me understand that process. And that's what I'm challenging you to do, and to think about that you can be learning and making observations literally wherever you are, and somehow, in my experience, wherever we are in the world, it feeds into this general pattern that we're just talking about now. So interesting. So this is another simple observation, observe and interact, observation that I made. This is a pile of what I would call brash. It's where someone's been clearing the forest at lots of old twigs, sticks, narrow diameter wood. It's been put in a pile. That's quite a good thing to do sometimes for creating perhaps habitat and shelter for other, maybe for insects or other animals or lizards or anything. And also allowing then that it's carbon, right? So if we've got a pile of sticks in our woodland, what we want to do if we put it into a pile is encourage them, as they break down, to be incorporated back into the soil. What we don't want to do is to rake them off and burn them, right? And in putting this pile of sticks, it's created a bit of habitat. And what's happened, nobody planned this, just happened by accident, is this is convolvulus, bindweed. It's a wild flower, a climber, and look how it's grown all over the pile of sticks. And I just thought it was interesting was to note that the sunny side, because again, this is in a temperate climate, so for us the sun is always in the south. It's never overhead, and so the sunny side of this mound that's where the plants have grown. They've gone to where the energy is. They've gone to where the sunlight is. And look, the north side, where there's almost no light, there's almost no plant, or the plant is there, it's really small. And that's another example of microclimate. And I think it's an interesting thing to have in mind is, consider how different the conditions are just from one side of this mound to the other. This side, we've got almost total vegetation that looks rich and lush. And on this side, we've got almost nothing. And what is there is small and stunted. So sometimes very small differences can make a big impact. And important things, just observe and help understand from what we see, so we can learn from what we see in nature. Okay, this is a library photo of a mature forest. And I'm trying to imagine that perhaps the forest has been there for millennia, hundreds of years, a long period of time. Obviously, it's going to be made up of big, mature, old trees and vines and all sorts of other things. But also, there's going to be small, young trees in between that are waiting for that opportunity, that if a big tree in the forest comes down, then suddenly there's a window of opportunity, isn't there, for those little seedlings to germinate and grow really fast. And one or two of them are going to win the competition to catch the light and then shade out the weaker trees again. So this is a very important observation. And the observation is that trees, many kinds of tree, especially when they're young, they have the ability to kind of sit. And if the conditions change, if the conditions are optimal, they will grow, they can accelerate, and they can grow a huge amount in a short space of time. So based on observation, this is what certainly our ancestors in the UK did, was they evolved a system which they call coppicing. And to coppice wood is we're growing trees and we're cutting those trees down at the base. But when we're doing it, we're doing it, look how there's a block. Whoops. This tree here has been cut down, that one, that one, that one, that one, so that there's a block, so that the sunshine, once after they've been cleared, sunshine shines in equally, and that stimulates the tree to grow back again. And here you can see on this old tree stump, there's lots of smaller regrowth is coming back. So we call this a stool, a coppice stool. And this has been, the tree's been cut in a way in which it encourages it to regrow, but this time with multiple stems. So these trees are actually called chestnut, and they were used in construction, but most of farming, gates and fences and small barns and animal shelters and things like that were all often made from the shape of the construction was made from these chestnut poles. Now, I see a lot of this in Uganda with different kinds of species of trees, but I don't see the coppicing part. So because these trees have been cut off at ground level, they've also been protected from grazing animals, because obviously grazing animals would eat off all of that regrowth, and they're in full sun, so that then the tree grows back again, and they've been protected from fire. So there's a few things there, but obviously once they get going again, once they're at a certain height, they're then protected from grazing animals, and if the optimum conditions are maintained, then they grow back really, really quickly. And you look how closely spaced these coppice trees are, and what that does is that creates then it stimulates the wood, the regrowth wood, to also be really straight. So this is a permaculture system. This is a permanent way of creating wood. That might be timber for building, or for energy, or for feed for animals even, in which there's permanently life going on. There's permanently roots in the soil, and so we're always protecting and working with that soil, and yeah. I'll enlarge on these things at first, but these are observations that we make from observing nature. We see that trees, when they're snapped off at the base, if there's enough sunlight and they don't get grazed, they grow back really, really quickly. And that in the process of doing that, we can also help build the forest system. So a lot of the landscape in the UK in the old days, so going back to maybe before the 1930s, was managed by hand, and it was managed to create lots of poles and lots of wood that was used in simple construction and for energy and making charcoal and all those other things. So here's someone managing. This is a hazel coppice, and what I can say from this picture is a real advantage here is that you can manage this with hand tools. You don't need chainsaws. You don't need big tractors to move the wood. You can carry it yourself. So working with narrow diameter, fast growing wood is one of the sort of working with nature insights that permaculture gives us. Maybe we should be moving away from felling large trees and thinking about instead how we can work with regrowth, with sticks, with narrow diameter wood that grows very quickly. And when we remove it from the plant, we don't kill the plant itself can grow back very quickly. So again, you can see that it's a very carefully managed stool, hazel coppice stool there. And when the next season begins, you'll have multiple branches growing back from that. So these are very, it's a very significant potential in these things for creating materials for building, for energy, and for fodder, in a way in which it's permanently producing. So I'm really keen to see much more of that going on in East Africa. So, well, here in the UK too. So, most important, how are we doing? I'm just going to do a time check.
It's 7.
It's 7. Okay. So what we have is, how is everyone? So I maybe,
We could have a break and then do the last 1 hour.
well, yeah. Okay, let's have a little break, and I'll stop the share and also stop the recording, and let's just take a little break, and we'll have a check out, see how everyone is feeling as well. Oh, stop live stream.
Yeah, sure.
Yeah.
And the recording.